Welcome, I am Mr. Murphy, and in this particular video we're going to be looking at skill number 27. Skill number 27 is looking at what we call exponential decay and depreciation. Now you might notice that we're going to be using an equation very similar, in fact exactly the same as far as the setup, y equals a times b to the x power, as what we saw in skill number 25. But this skill is looking at what we call, again, depreciation. So instead of, in skill 25, that talked about population growing and increasing in value, depreciation and decay is looking at our population decreasing in value, or decreasing in its amount. So again, the setup is going to be very similar. There's going to be some slight changes, though, that are going to be that we're going to be using in this particular skill. But let's look at an example that we'll be doing on your own here in a couple of minutes. So the example that you'll be doing on your own is this one, dealing with the population of Hawaiian monk seals. And this particular story problem is saying that, let's say the population decreasing by a rate of 3.4%, which is actually true. Look this up on the internet. That's where I got this problem, because I always think it's good if we're dealing with story problems that have some real life applications. So if you look this up, this would actually be what's currently happening with this population. So it's decreasing in value they're decreasing in value by 3.4% annually. And there's currently about 1,100 monk seals in Hawaii. And we want to figure out, if the population continues to decrease at this rate, what's the population going to be like 10 years from now? Well, in order for us to be able to approach this problem, we need to make sure that we know how to use that equation, y equals a times b to the x power. And so let's take a minute, let's talk about that. So again, if you notice, I've identified the parts. The parts still look the same, where a is still representing our initial amount, what we're starting out with. B is still what we call our growth factor, which we'll be talking about in a minute. And your x is going to be representative of your time in years. Now back in skill 25, we talked about the fact that when that value for b is greater than 1, that it represents exponential growth, or that we're increasing exponentially. Well, since we're talking about depreciation, or our population decreasing at a continual rate, that value for b is going to be between 0 and 1. And that rate is going to be as a percent. Now back in skill 25, since we were increasing in value, we took our 100% of what we had originally, and we added whatever the percent was that we're increasing by. But since we're talking about depreciation, we're still going to be using 100% of what we had before, but we're not increasing, we're decreasing. So we're taking away from what we had before. So we would take whatever the percent is and subtract it from 100. So let's see what I mean by that by a different story problem. Here it says, suppose a new car bought in 2008, we bought it for $14,675, depreciates at a rate of 15% each year. We want to predict what the value of that car would be in the year 2015. So let's look at that percent for a second here, that 15%. That 15% means that we had 100% of whatever the car was bought for originally, but it's losing 15% of its value every year. So that means the amount that we're retaining is 100% minus 15 would be 85%. So every year it's still worth a total of 85% of what it was originally. So 85% is going to be the rate that we'll be using. So let's see how we plug these into our formula. Let's start by identifying our values for a, b, and c. We already talked about, or not c, a, b, and x, because remember the equation is y equals a times b to the x power. So our value for a would be what we start out with initially. Our initial amount is $14,675. Again, we talked about the fact that that 15% represents 100% that we had originally. We subtract 15%, so we get 85%, which as a decimal is 0.85. And we want to figure out what the car's value is going to be in the year 2015. Well, if the car was bought and purchased in the year 2008, well, 2015 would be 7 years later, so our value for x would be 7. So when we plug these numbers into our equation, our amount is going to be 14,675 times our value for b, which is 0.85, being raised to the x power, which is 7. So we're going to take and plug this in on our calculator. So So the way that we're going to do that is, again, we're going to start out with the 14,675. And then in parentheses, we're going to put our growth rate, which is 0.85. And we're going to raise that to the 7th power. And again, since we're dealing with dollars and cents here, we want to make sure that we round this correctly. And we look after that 6, and we'd round this up to 7. So our value would be $4,704.47. So if we go back, this would be $4,704.47 would be our answer. So that would be the car's value 7 years after it was purchased. So it makes you think about buying a used car. Might be more financially wise as opposed to buying a brand new car. Okay, so I want you guys now to apply this to this Hawaiian monk seal problem. So I want you guys pause the video and hit play when you're ready to check to see if you did it correctly. Okay, so for this problem, again, we're decreasing by 3.4%. So if you subtract that from 100, you get 96.6%. So when we identify our values for A, B, and C, our value for B would be 0.966. Our value for A, our initial amount, is the 1,100 seals. And I don't know why I keep using C, but we should have X. But our value for X would be 10, because it would be 10 years from now. Okay, so when we plug these into our equation, it's going to be Y equals your initial amount times 0.966, and our exponent's going to be 10. And since we're dealing with animals, we're not going to use a decimal as our answer, so we'd say that we'd have approximately 778 seals in 10 years. Well, there you have it. That is skill number 27. So hopefully you have a better grasp and feel like you have mastered this skill and know how to apply that Y equals A times B to the X power now to situations involving depreciation as well as exponential growth that you did in skill number 25. So with that, good luck.